Recording in progress.
Right, so I was saying there is a change in velocity, and you might be confused about that because the numbers are the same, it's 2 and 2. But velocity is a vector quantity. So I'm not only looking at the magnitude, which would be the 2 meters per second, I'm also looking at the direction. The direction changed from right to left. Because there's a change in direction, that means that I have a change in velocity because I'm looking at magnitude and direction. Because there's a change in velocity, that means that I have an acceleration. Okay, do you understand that? Meaning the magnitude and direction has to correlate, right? Yeah. Can I take this off now? Right, on to this now. Uniform, like I said, uniform means constant. Constant means it's staying the same, right? So if I have a constant acceleration, aka a uniform acceleration, that means that it's the same acceleration. The velocity changes by the same amount in every second. So what does that mean? Let's say, let me put these points, this point, this point, this point, this point. Let me say this point represents 1 second. So my body is here, right? Let me just put a circle. My body is here, but I'm only starting counting here, right? So 1 second, this is 2 seconds of moving, this is 3 seconds, this is 4 seconds. So I want to check the acceleration at each of these points. After 1 second, after 2 seconds, after 3, after 4. Yeah. So this is my body. Body means object, right? It's a physics thing. So you might hear body, you might hear object. Yeah. So at this point here, let's say, let me go back to the 2 meters per second. And then at this point, I realize it's also 2 meters per second. So from this point, 1 second to 2 seconds, I realize this is still this way, right? Because my magnitude and direction are the same, then I have the same, let me not do that. Let me not do that, because then I'll have no change. Let me do left and, no. Let me do 4, 2 and 4, 2 and 4. So different magnitudes, I have 2, I have 4, but the direction is the same, right? But because velocity is a vector quantity, yes, my direction is the same, but my magnitude changes, which means that there's a change in velocity, right? That's what we just went through. So at 1 second, I recorded this 2 meters per second and it's still traveling to the right. Then I recorded it again at 2 seconds. The body is still moving to the right, but now it's traveling at a speed of 4 meters per second. Okay, so I know there's a change in velocity, right? And we just said just now, if I want to find the change in velocity, it's the final velocity minus the initial velocity. So that's positive 4, because we said going to the right is positive, right? We're taking that as positive. So positive 4 minus positive 2 would give me my change in velocity, which is 2 meters per second. And it's still going to the right. So it's positive 2 meters per second. But what's the time between these 2 points? Well, it's 1 second, right? From 1 second to 2 seconds. That's me traveling 1 second, right? So what does that mean? In 1 second, so dealing with these two, in 1 second, there was a change of positive 2 meters per second. So my velocity, the change in my velocity was positive 2 meters per second in 1 second. Okay, so now I want to check what exactly is my velocity at 3 seconds. So let me, what color? Blue? Right. So my body still traveling to the right, but this time it's 6 meters per second. And I want to find my accelerate, well, I want to find the change in velocity from this point, so 2 seconds, to this point, 3 seconds. So again, the change in time, or the time taken from this point here, 2 seconds to 3 seconds, that's still 1 second, right? So 1 second. But what's the change in velocity from this point to this point? Well, I will tell you, change in velocity from my formula, it's the final velocity minus the initial velocity. Final velocity is 6, and the initial is 4. So I would say positive 6. Let me just not write the positive sign, right? But you should write it. Okay, let me write it. Positive 6 to indicate that it's still going to the right, minus positive 2. That's me trying to find my change in velocity. Final minus initial. No, why am I putting positive 2? It's positive 4. This is 6 and this is 4. I'm checking between these 2 points. That's positive 2 meters per second. So what did I just find out? In this first second here, from this point to this point, that's 1 second. The change in velocity was positive 2 meters per second. Then I'm checking from this point to this point. It's also 1 second, right? From 2 seconds to 3 seconds, that's 1 second. I just found out that the change in velocity from this point to this point is also 2 meters per second. Okay, let me do another one. Body still moving to the right, but now it's 8. And I think you would see where this is going. If I want to find a change in velocity, final velocity minus initial velocity, which is 6, because I'm trying to find the change in velocity between these 2 points here, is equal to 8 minus 6 is positive 2. So again, in 1 second, my change in velocity was positive 2 meters per second. See where this is going, right? So the definition of a constant or uniform acceleration, being that the acceleration stays the same, is that the velocity changes by the same amount in every second. In every second, I had a change in velocity of 2 meters per second, positive 2 meters per second. So the same change in velocity in every second. So what does that mean? That this acceleration is constant. I have a constant acceleration. This body is not speeding up and it's not slowing down. Well, let me not say no. Let me just say it's not getting faster and faster. Right. Do you understand that?
Yes, miss.
Okay. Can I clear this?
I think so. So far.
Okay. Can I clear this in?
Yes, miss.
Okay. Deceleration. Deceleration just means a negative acceleration, right? So the velocity actually decreases. My bad. So, like I said, diagrams always help. Diagrams always help. So let's say my body, 2 meters per second. But then I tell you down here, still to the right, but I'm actually moving at 1 meter per second. Velocity decreases because it goes from 2 to 1 and we still move it to the right. So my velocity decreases. Because my velocity decreases, I have a negative acceleration. Let me just show you how that math works. If I wanted to find, let me say this is 10 seconds. 10 seconds, right? Oh, no. 10. Okay, let me just leave you 10 seconds. From this point to this point is 10 seconds. So I want to find the acceleration, right? It's final velocity minus initial velocity divided by the time taken to get between the time taken to move from this point to this point. So let's say I wanted to calculate this acceleration, right? Final velocity would be 1 minus initial, which is the velocity I start with, that's 2. So remember your signs, right? Positive, positive. Divided by the time taken, which is 10 seconds. So this is 10 meters per second. Positive 1 minus positive 2, that's going to give me minus 1 meters per second, well, meter per second, and then 10 seconds. So I would say, okay, 0.1 meters per second squared. So yeah, I have no space there, but let's just pretend the unit is there. This is the unit, right? I work it out and I get a negative acceleration. There it is 0.1. And you might think, well, this has to be wrong. How can I have a negative acceleration? Well, negative acceleration just means that it's a deceleration. And what does deceleration mean? My velocity decreases. As you can see here, I went from a positive 2 to a positive 1. And that's all that negative sign means. It's called a deceleration or negative acceleration, meaning that my velocity from one point to the next decrease. Do you understand now? Yes, no? Yes. I'm clearing this, right? 3, 2, 1, click. Okay, and there's some things you need to note. Like especially these phrases, a particle is instantaneously at rest. That's a very common phrase in your past paper question. And then maximum velocity. So just look up for these phrases, right? Particle instantaneously at rest. Oh, let's just pretend that underline. Oh, yeah, anyways. And then particle reaches maximum velocity. So if I told you that a particle is at rest, instantaneously means at that point, right? At that point, the body is not moving. At rest means that it's not moving, it's stationary. What does that mean? That my velocity is 0. So you need to know that, right? If I have a 0, right, velocity is 0. Remember that. Particle reaches maximum velocity. That means that my acceleration has to be 0. You might be wondering, but how would acceleration be equal to 0? Well, if I reach my maximum velocity, let's say the maximum is 8 meters per second. That's my maximum, so positive. Let's just say I'm going to the right. Positive 8 meters per second. That's my maximum velocity. I cannot exceed that value. I can't do 8.1, 8.000000001. No, I cannot exceed 8. That's my maximum velocity. So if I check the velocity at this point here, and I see that it's positive 8, and then I come over here and check it again, still going to the right, it will be positive 8. It would still be positive 8. Why? Because that's my maximum velocity. I cannot exceed this value of 8. And if I can't exceed the value of 8, then at this point, it would still be 8. At this point, it would still be 8. At that point, it's still 8. And if you use the formula for acceleration, which is final velocity minus initial velocity divided by the time taken, let's just say this time is 2 seconds. 2 seconds. 2 seconds. From this, between these 2 points, final, which is 8, minus initial, also 8, divided by the time taken is 2. 8 minus 8 is 0. 0 divided by any number is 0. Therefore, my acceleration is 0. And if you look between these 2 points again, it's 8. It would also be 8 minus 8 divided by 2. It would give me 0. 8 minus 8 divided by 2 is also 0. So as you can see, at my maximum velocity, meaning that I cannot exceed that velocity, that's my limit, the acceleration would be 0. Do you understand that?
Yes, miss.
Okay. Any questions? Because we have to move on to graphs now. But before I do that, any questions about this? Okay. Well, let me just show you where we are in the syllabus right now. Where is it? Okay. So what we just, hold on, I don't think you can see that yet. Okay. What we just did was these definitions. So displacement, velocity, speed, uniform velocity, acceleration, negative acceleration. All right, retardation. A deceleration is also called a retardation. So just note that, right? I've never seen this too in the past, on your past papers, but still, just note it, right? Uniform acceleration, instantaneously at rest, maximum velocity. Now we on to graphs. So as you can tell, we just covered everything they require you to know for the definitions and all that, right? But like I said, kinematics, you have to know how to not just plot the graphs, but interpret the graphs as well, because you may be required to pull information from a graph to do all your calculations. So it's important for you to know how to read off a graph and understand what's taking place, and also how to draw the graph. Because, like I said, it's only 2021 paper that you weren't required to do the graph, like draw it on graph paper and all that. Every other year, you had to do that. So that's why it's very important, okay? Right, so let's go back to, I just want you to note one thing. All right. So there, according to your syllabus, right, there are two main graphs that they want you to know. Displacement time graph. We're going to do that just now, right? Displacement time graph, see, displacement time graph. And velocity time graph, right? That's the only two graphs they mentioned, displacement and velocity. But if you look at your past papers, you would notice that some of the questions actually ask you for a distance time graph, and then others ask you for speed time graph. The graphs are similar, right? But not exactly the same. So for somebody who did not know the difference between a displacement time graph and a distance time graph, or the difference between a velocity time graph and a speed time graph, it could have messed you up, right? Which is depressing because it's not on your syllabus. So I don't understand why they would bring it in the exam if they did not state it on the syllabus, right? But anyways, I will show you what to do. So you won't be surprised if that graph just shows up in your exam. I remember the kinematic section is mandatory now, right? You have no choice. You have to do kinematics. Right, so you are required to know two graphs. That's why I put two graphs here, right? Two types of graphs, because they only stated two types of graphs, the displacement and the velocity. But like I said, it was tested in the exam, distance time and speed time. So I have it on the PowerPoint. So yeah, the graphs, displacement time, distance time, velocity time, speed time. I have the asterisk here because, like I said, it's not mentioned in the syllabus, but has been tested in exams. Displacement time graph. What are the key features that you're required to know to sketch this graph and to pull information from the graph if you're required to? So for displacement time graph, displacement, which is in meters, remember the unit is meters, is on the y-axis, and then time is on the x-axis. My physics students, you would know this because your kinematics is actually a topic for physics. Right, so y is the vertical, x is the horizontal. So this is my y-axis, this is my x-axis. So if they ask me to do a displacement time graph, on the y is displacement, so let me just put d, and the unit is meters, and then x-axis is time, so I just use t to denote time. Unit is seconds. So that's how your axes would look. The gradient of the graph is velocity. How? You might be wondering, how is that velocity? Well, if you go back to your definition of velocity, let me go back to the definition of velocity. Definition, look my diagram. Anyways, the definition of velocity is the distance traveled per unit time in a specific direction. Okay, what does that have to do with displacement? Well, looking at this, distance traveled per unit time. Oh, I went too far. Distance traveled per unit time. Nope. Hold on. Right. Distance traveled per unit time in a specific direction. Distance traveled in a specific direction. Displacement is the distance traveled in a specific direction. Velocity is the distance traveled per unit time in a specific direction. So if I just rearrange these words a little bit, right? Let me just take off per unit time. And I said, velocity is the distance traveled in a specific direction. Then I put per unit time. Notice this right here, distance traveled in a specific direction is the same as this, distance traveled in a specific direction. So what does that mean? Well, velocity, since this is displacement, and velocity is the distance traveled in a specific direction per unit time, this meaning displacement, then I can actually manipulate this definition. And instead of putting this long thing, I could actually say velocity is the displacement. So I just put it for displacement per unit time. Notice how displacement and velocity are related. So instead of putting this long definition, the distance traveled in a specific direction per unit time, this is the definition of displacement. So velocity is really the displacement per unit time. And that's why, and remember, per unit time, that also indicates divided by time, right? So it's displacement on time. keep this in mind. Displacement on time is the same as velocity. Right. Let's just say this is my graph, straight line through the origin. And I want to find the gradient of this line. You know, you take 2 points on the line. So let me just say I take this point, I take this point. I read off the x value, I read off the y value. So this is my x1, this is my y1. Then this is the other point I'm dealing with. So I read off my x value, x2. And then this is y2. And we know the formula for gradient because we learned that a long time ago. Remember, gradient can be denoted by m. And it's y2 minus y1, or some people say the change in the y values divided by change in the x values. Or you can use this, y2 minus y1 divided by x2 minus x1. And when I say y2 and all that, I mean these values right here, right? The values that you would read off. Notice from this graph, I said the y-axis represents the displacement, which is in meters. So you see these y values, they would actually be displacement values, right? So I can say, instead of saying y2 minus y1, I know that these values here are values of displacement. So let me just, m, I can replace this with displacement. My x values, I know that this quantity on the x-axis is time. So I can replace this x2 minus x1 with time. And we just said that another way of saying velocity is the displacement per unit time, which is displacement on time. This is displacement on time. And therefore, the meaning of my gradient for this graph has to be velocity. And that's why the gradient of the graph is velocity. Do you understand that? If you don't, I can explain it again. Yeah, okay, thank you for answering. So I understand. Nice. So just leave that for a little bit. And then there's a point you need to know. The steeper the line, the greater the velocity. How do I know that? Well, let me just erase this on top. When we are doing coordinate geometry and we're doing straight lines and all that, and as the first time, you met this concept of gradient with me. We said the steeper the line is, the greater the gradient. So let's just say all of them passes through the origin. So I have a line going this way. I have another one looking like this. And I have another one looking like that. When we were doing coordinate geometry, we said the steeper the line, the greater the gradient. So this gradient would be like the value for this gradient. Let me just say it's 0.5 would be less than the value for this gradient. Let's say it's 1. And then this would be less than the gradient for this one, because this line is the steepest. It's 2. So as the line gets steeper, the gradient increases. So what does that mean? Because the gradient of my graph, this displacement time graph, is velocity, that means that the steeper the line, the greater the velocity. So let's just say this represents my velocity. So 0.5 meters per second. That's my velocity for this line. But if I calculate the velocity for this line, I end up getting 1 meter per second. And then for this one, 2 meters per second. So as you can see, the steeper the line, let's just say the closer it is to the y-axis, which means the steeper the line, the greater the velocity. Okay, next point. A straight line shows that the object is moving with constant velocity. Straight line. When they say straight line, I mean like this, right? Straight line through the origin. Well, yeah, not really, not necessarily through the origin, but a straight line. Okay, constant velocity. How is it constant velocity? Back to college geometry. Notice how all of these things are linked, right? So you can't get away with, okay, I did college geometry so long ago, maybe I could revise that after I finish everything. Because in a way, all of these topics that you're required to know are linked in a way. So you see college geometry is coming into kinematics, and then you'll see differentiation and integration in this too. So it's really important for you not to forget what you learned previously, right? Because it's required for more quote unquote advanced topics. So we know from our college geometry that the gradient of a straight line is constant. So the gradient of a straight line is constant. And I said that the gradient is velocity. Straight line, gradient is constant. My gradient is velocity. What does that mean? Velocity is constant. Let me just write that out because I know some people learn differently. So straight line, I have a constant gradient. The gradient between these 2 points, let's say I use these 2 points to find my gradient, would be the same as the gradient between these 2 points, which would be the same as the gradient between, let me just highlight this in green, these 2 points. That gradient is constant. It doesn't matter which 2 points you choose on this line, the gradient would be the same. So I could use a point here and a point all the way up here, a point here and a point in the middle here. I would get the same gradient because the gradient of a straight line is constant, it's the same. So if I say m, which is gradient, is constant for a straight line, we just said that the gradient for this particular graph, displacement time graph, is velocity. So gradient is velocity. And because we said the gradient has to be constant, the velocity, which is my gradient, is constant. And that's what they meant. Hey, straight line shows that the object is moving with constant velocity. Do you understand now?
Yes, miss.
Okay. Clear this whole thing. A curve shows that the body is moving with varying velocity, i.e. it is accelerating or decelerating. I'll tell you why I said that just now. So again, your y, your x, y is displacement, x is time. Let's say my curve looks like this. And it's going down. Okay, let me know. Anyways, it's just a random curve, right? Let's just say the curve look like that. Or you might have a curve looking like this. I don't know. Just a curve. It's not a straight line. It's curved. So why would I say the velocity is varying? Back to differentiation and all that. Can anybody tell me, if you have a curve, let's say, if I have a circle, and I wanted to find the gradient, actually no, let me not use a circle. Let me just use an exponential curve. So like a curve like that. and I ask you to find the gradient of the curve at this point here, what would you do? This is not a straight line, so I cannot apply the formula m is equal to y2 minus y1 on x2 minus x1. So if I ask you to find the gradient of the curve at this green point, can anybody tell me what you would do? I didn't do this with you yet, but I want to know if anybody knows what you would do. No, go in once, go in twice. Okay, well, I guess you didn't meet this yet. That's fine. If I wanted to find the gradient of a curve at a point, obviously I can't use the formula that I would use for a straight line. Oh, don't understand the question. To find the gradient of a straight line, I would use the formula m is equal to y2 minus y1 over x2 minus x1, right? I choose 2 points and I substitute values and that's it. Do you remember that? Troy, do you remember that? Right. But if I have a curve looking like this, and they ask me to find the gradient of this curve, with the gradient at each point on this curve. So let me just draw 2 random points. The meeting is gonna end soon, right? And it might cut off on me while I'm explaining, but just rejoin. So let's say I have a point here. I want to find out the gradient here and here. Would the gradient at this point be the same as the gradient at this point? A straight line. The gradient is constant. So at this point, the gradient would be the same as this point, would be the same as this point, and so on. But for a curve, no. No, it won't. For a curve, the gradient is, yes, it's different at each point. But how would you find the gradient at the point? Okay, the meeting is gonna end, right? So just read it. Just think about that though. Let me end it.